for 8B.5, we're just going to be looking at statements about logs, rewriting them, kind of like a review of what we've done so far. So can somebody give me an example of an exponential function? Anybody? What? We can go even simpler than that. How about 5 squared equals what? What's 5 squared equal? 25. 5 squared equals 25. That's an exponential function. Okay, we have an x, we have a y, and it's an equivalent equation. So how would you write that as a logarithmic equation? Log base what? Log base 5 of 25 equals 2. Okay? So what we want to do for the examples, we have 7 examples. Let's look at 1, 2, and 3 for right now. All you need to do is write equivalent statements. So can you guys do that on your own for right now? So all you need to do for 1, 2, and 3 is write an equivalent statement. So if it's in log form, write it in exponential form. If it's in exponential, write it in log. That's all you need to do. So what'd you get for number 1? Log base 27 of 3 equals 1/3. Good. Okay, so number 2, it is in log form, so we need to write it as an exponential function. So what's that going to be? X to the z equals y. All right, number 3. We have log of d equals g. If I have log with no base, what is the base? 10. Okay, so that's going to be what as an exponent? 10 to the g equals d. So 10 to the power g equals d. Okay, so even though we're in all variables here, we still apply the same rules. Okay, so let's look at number 4. When is the following statement true? 2 to the log base 2 of x equals x. This is a special case, right? If I have 2 raised to the log base 2, what happens there? They cancel, so we're left with x equals x. Is that a true statement? Always. Yes, it is. So what's the answer there? A. Let's think about it. Well, think about it, guys. If we have log base 2 of x, okay, this is going back to what we had to correct on at the very, very beginning of class. What's one thing that I know about that x? It has to be positive. Must be greater than 0. So what would my answer be? B. Remember, our answer can never be negative. Okay, so one thing we do have to remember about our answers here is that it can never, ever, ever be negative. So we have to only look at values of x that are positive. So it's not for all values of x, it's only for some of them. Okay, does that make sense? You guys okay with that? That's just something we have to memorize and remember, that the answer can never be negative. What else can never be negative? The base can never be negative either. Okay, so your answer can never be negative, your base can never be negative. Okay. Number 5, write an equivalent statement to log base 2 of 32 to the x. 32 is the same as 2 to the what? 2 to the 5th. So can we rewrite this first? Log base 2 of 2 to the 5x, right? Okay, this is we can set the whole thing equal to x. This is also a special case. If we set it equal to x, we get 2 to the x equals 2 to the 5x. We can drop those bases so x equals 5x. So our answer is 5x. Well, I guess we wouldn't use x, right? We should use y. But this was a special case, right? If I have a base and my base of the exponent is the same, I could cancel those out right away, and we know that my answer is just going to be the exponent. Do you guys remember that special rule? If they are the same, you can just cancel them out. So our answer is just going to end up being that exponent of 5x. Okay. Okay, what about number 6? Same type of thing. Will you guys do that one by yourselves?
2x.
Log of 100x is the same as log base 10, right? Of 10 to the 2x, which means we can cancel out that log base 10 and that 10, so our answer is just the exponent of 2x. Good. Okay. So last one, number 7. This is like a review all the way going back to 8A. If the equation of y equals 1/2 to the x power is graphed, which of the following would give us a point closest to the x-axis? So what's the, I know these ones. What's the first thing we should do? We should make a table. X and y's, right? What do we always plug in for x? 2, 0, -2. Because we're just looking to see what happens when x is positive. We want to see what happens when x is negative. And we want to see what happens when x is 0. So if x is positive 2, what's y going to be? 1/4. If x is 0, y is 1. And if x is -2, y is positive 4. Okay, so let's graph it and see what happens. So off to the side here, I'm going to draw a graph. Our biggest number is 4, so let's just go 1, 2, 3, 4. 1, 2, 3, 4. Okay. So let's graph this thing. 2 1/4 is my first point. So x is 2, 1/4 is somewhere in between 0 and 1. 0 and positive 1 up here. And -2, positive 4. So my graph is going to look something like this. Will it ever touch the x-axis? No, but it will get really, really close. Okay, is this decreasing or increasing?
Decreasing.
Good, it's decreasing because it's getting smaller as x gets bigger. So which point is going to produce a point closest to the x-axis? Are we looking for the biggest x or the smallest x?
The biggest.
The biggest x. So which one's biggest here?
2.
C. D, 5/4, is really 1 and 1/4. So 2 is bigger than that number. So our answer is C.